Okay, welcome to this video. What I would like to do is to explain how to make a footprint, a custom footprint in EasyEDA online. So the component I'll be using is this MEMS mic from I think it's ST. There's the part number. So it's got 1, 2, 3, 4, 5 pads, and the one I want to focus on is this annular ring. So it's a copper ring with no copper in the middle, and then there's a hole in the middle. So it's a bottom port MEMS mic, and the audio comes through the bottom over here after it's been soldered on. If we go down to its dimensions, so here's the land pattern dimensions, and this is the stencil openings. So you can see there's two inner and outer circle. The outer is 1.625 millimeters and the inside is 1.025. But for this purposes I made a drawing, and I'm just going to use different dimensions just to make it easier. And I prepared something in paint just to make it easier to understand what I'll do. One thing you need to notice is the stencil opening looks a bit different. The stencil opening can't be just a full annular ring, because then the middle will fall out of the stencil. So there's openings where the metal part of the stencil will come in. So just put paste on this half and this half, and then that should be enough to let the solder flow. So I made a drawing. So for the one that I'll draw, I'm going to use 0.35 millimeter inside diameter, or inner circle radius, 0.35 millimeters, and the outer is 0.65. So it means the midpoint over here, like if you draw a circle in the middle, it would be 0.5 radius or 1 millimeter. So it's a bit different than that. It's just to make it easy. And then for the annular ring, you'll see they have a 0.3 millimeter opening. So if you take this as the y-axis in the middle, then it would be 0.15 offset to that line over there. But what I did is I just used the 0.1 millimeter. So I see this blue long line is my y-axis and my x-axis. So I drew two triangles, 1 millimeter. So I'm just going to draw the 1/2 and then flip it. You'll see that later. But anyway, let's start drawing, and then I can show you how it's done. So if we go to EasyEDA, that's the Pro online version. There you can see it. So what I did is I just started making a component. It's just file, new component, and I just draw a box with 5 pins, as our component has 5 pins on. And what I will do now is to create a footprint for this, and then later on we're going to link them. So new file, new footprint, and I'm just going to call it test. Save. Duplicate title. Test 2. Looks like I already have. Okay, there's my footprint opening up. Okay, I want to spend more time on the annular ring to explain how to do that. So I started off trying with implementing a pad, and then setting the pad parameters to get my annular ring. But the problem is it has a hole in the middle, and the hole where the hole ends, the copper start. But if you look at our design or our footprint, it needs to have copper, then no copper, and then the hole here. So it's a little bit different, and I couldn't get to adjust this one to do what I need to do. Then the other thing I tried was to place a circle. And make it a fill region, so it fills with copper, and then to put a void, or a, what do they call, prohibited region, thinking it will prohibit any copper in the middle, but that doesn't really help. It still creates copper. Then what was the other way I tried? Then I tried to here by line, I thought, okay, let me make a circle. Okay, that's a track, and then I just set the track width. You can set the line width to, let's say, 0.5 millimeters, or adjust it to whatever you want. That looks perfect. But currently it's a track, and we need to specify it as a pad, so you can link pin pad numbers to it. Currently there is no pin pad number. So if you click right and you say convert to pad, boom, you see there you can create a pin number 3 in our case. See your solder mask layer, but also this creates a full copper, so that didn't work. So what I ended up, I found a video somewhere, I can't find it again, but basically what you need to do to create an annular ring is to use a 2-point arc. So I'll use a 2-point arc, and if we go back to, we're going to use this profile. So later on this coordination, or what is it, coordination points over here is just that point over there and that point over there. I'll later on show you what I'll do. So this is our copper area. To make it more visible, let's just fill in some orange over here. So that's going to be our copper area over there. Okay, so our copper area is basically 0.35 to 0.65, and the midpoint is 0.5. So it's got a 1.5, so it's got 0.3 thickness, and the midpoint is 0.5. So what I'm going to do is I'm going to select my layers, top layer, line width is 0.3. Okay, and then the start point on the X is 0.35. No, sorry, it's 0.5. That's the midpoint, and the X endpoint is also 0.5, and that's it. And then I say full rotation is 180. Okay, then I create another one for the top side. Okay, and I set it also to the same parameters, 0.3 thick, 0.5. See if this is fine. Yeah, it looks fine. So there's my copper ring. Now I can click right and say convert to pad, and you'll see, boom, there it creates a pad. And the moment you select the top one, convert to pad, there's my copper ring with the solder masks perfectly as I want it. But now you see the pin numbers is different. We want it the same. Our data sheet says pin number 3, so you select those two and create both to be 3. So here we can see our solder mask layer and our top layer, and we even have a top paste mask layer. So let's just add an opening, prohibited region, this one, slot region, circle. It's just for the, not going to worry about size, but that's to create the hole in the middle where the bottom port for the audio is. Right, so that is that. But now the problem is, if you look at this over here, our stencil opening looks a bit different. Stencil opening have slots over there and there. It's not a continuous copper ring. So you see, if I look at the stencil, it's continuous, and that will create problems. So we need to customize our stencil. So that's where this drawing now comes in. So I'm going to use this coordinates to basically manually draw the stencil two halves and create basically a new stencil. So I'm going to follow this coordinates. So first of all, so what I found is, if you draw lines or arcs and then try to move it to snap to certain points, it's not very efficient. The best way is to use coordinates where to start and stop, and that's why I'm using this coordinate system to draw it exactly to this specification here. But you can do your own specification, own diameters and radiuses, and get your own coordinates to whatever you need. Okay, so basically let's use the top silk screen to make it more clear. Okay, so I'm going to draw a line. So we need a line somewhere here. So one thing I couldn't figure out is how to make your default line thickness. So I want to draw 3 lines. I'll show you in a moment why. In the line thickness, I adjust to 0.01 millimeters. And then what I'm going to do is I'm going to use this drawing of mine. So basically the lines I'm drawing now is an offset 0.1 millimeter of the y-axis to this side. Remember, we're only drawing the right-hand half of the silk screen on the solder paste opening. So my line is offset 0.1 millimeter. That's this 0.1 millimeter. So from that coordinate to that coordinate, remember, this coordinate is a mirror of that, or this coordinate is a mirror of that, so the minus will become a plus. So my top point here is 0.1 and 0.64. I'm just going to move this over here. So if I select this line, this one here, and then I can say the start x is 0.1 and the end x is the same, and the y is 0.3354, and the end y is 0.6423. See, there's my lines exactly on the copper end points. I'm going to do the same for this one. Start x is 0.1, end x is also 0.1, and my y, start y is minus 0.3354, end y is minus 0.6423. Minus 0 point. Okay, there's that one. And then this one over here will be basically the two radiuses. My x, my y's will be 0. So my start x will be 0.3, what is it, 0.35, and my end x will be the other radius, It's 0.65. There we go. Then I'm going to take this 3-point arc. Yeah. So then I select the endpoints here. This one. Okay, this is where I did something else. Yeah, I selected a different, because of that line thickness, it covers the points. So what I do now, I select a different layer and I hide the layer. Then I do that again. Select the endpoint there. See, then it doesn't show you the line. It doesn't cover the points, so you can exactly see where you want to. Ooh. Okay, so I did it the wrong side. I need to go from the top to the bottom. Let's try that. 1, 2, 3. Also not. Undo. Maybe top, bottom, and end. Top, bottom, and end. Yeah, there we go. So now what I do is I enable that layer, select the layer, change it to top silk screen and make the width 0.01. See, there's that line, and then I can do the same by hiding that one and selecting that one, and that one. Okay, enable that layer, select it, line width 0.01. Okay, and then change it to top silk screen. Right, let's delete that one. Then I'm gonna hide all and just show the top silk screen, select it, and then change it to top solder mask layer. Yeah, select it again. Okay, now we have to enable that one. It's now hidden within that. Let's see if we can do undo. Let's hide all that one. Now let's see. So we make it a full region. Figure is not replaced with alter conversion. Okay, and then we say, so it's a full region, and we make it top solder mask layer. Boom. So now it's going to be on top of here. You can't select the solder mask layer for some other reason, but you can't see it now. It's on top of the other one. So let's quickly do the other side as well. Okay, I'm gonna select that and draw a line. Someone can show me how to select my line default thickness. That will be nice. Okay, then we say 0.01 thickness, and then we go select the coordinates. So now my x is minus 0.1 and my start y is 0.6423 and my end y is 0.3354. That's that. this one -1 and -1. Start Y -0.3354 and end 0.6423. That one and this one gonna be my two radiuses again. X is gonna be -0.6423 and this one 3354. Something not right. Sorry, I didn't use the radiuses. The radiuses is 0.65 and 0.35. Okay, that's that. Let's draw. Now we're gonna hide again the next layer. 3 points, and we select that one, and that one. Let's do the other one as well. Select that one, that one, that one. Okay, let's enable that layer. Select these two, make it 0.01, 01, and we say it must be top silk screen. Okay, delete that. Select that, say type, make it a full region, and then we select it again and say top solder mask, top solder mask. Boom. Alright, so let's put on all our layers. So for the pads, I'm not going to spend too much time. That's basically just square pads. Just say create a pad over there, full region, a top assembly, top layer, and confirm. So let's say there's one pad, copy, paste. Anyway, we can align it later, easily copy, paste. So then let's select that and we say left align. Say that and we say right align. And we select that and we say top align and that. Okay, then we say these ones we must make them pads, convert to pads, and there they are, pads. So I'm not going to worry about their dimensions and positions. It's more about the annular ring. So now if we go back to our data sheet, you can see the pins are 1, 2, 3, 4, 5. So we need to make this 1, 2, this one is 3 already, 4 and 5. So that's correct. Okay, now the other problem we still have is this solder mask or the top paste layer is still continuous. So what you need to do here is, how did I do this? There was a Oh yeah, so basically you select your top and bottom halves that you created on the annular ring, and then on the solder paste mask expansion you click custom. So then you have your solder mask expansion and your paste mask expansion. So this is relative to your copper layer. So your solder mask you'll see is a little bit bigger. That's the purple ring that sticks out and in to cover that area. And your paste is 0mm, meaning the paste is exactly the size of the copper. So what I'm going to do is you set this to a negative number, then it removes the paste layer of that, and set this one custom, no, not thermals, custom here, -1, that removes that. Then when you go back and you say hide this one, let's hide this layer. Okay, so let's try it again. I've changed the solder paste layer to silk screen, and let's do custom -1. Okay, now if we go to solder paste, and then if we convert this to layer, top solder, solder mask, solder top paste, mask layer. Oh, sorry, I can't select that as well. Full region top paste, full region top paste. Okay, now if we enable all, then you will see we undo a little bit too much. Our footprints is skew now. Just align them here again, and this one right aligned, and then you say we want this to be converted to pads. This is 1, 2, 4, and 5. Okay. Why is this top layer? Where's my red? Oh, there we go. Okay, so if we hide all, then we'll see that's our paste layer. Good. Then we save this, and then what we do is we go to devices and we say link to existing device. I select my test, the one I created at the beginning, and then its association is successfully. So let's try and put it down on the schematic. Place device, there's my test. Place, cannot place, create project. Place device. Personal project. Okay, there we go. Place, okay, there it is. Let's go to our PCB and see if it places it there as well. Let's say design, update, convert schematic to PCB. There we go. Oh, I didn't put the yellow markings on the outside, but anyway, that can be done. There you have it. So here's the real one that I created. Perfect. Thanks for watching.